We've been looking at series for a while now, and the series that we've been looking at look like this. We've been presented with maybe n goes from 1 to infinity, 1 over n. And notice that there's no variable x in there. Well, what we're going to look at now is what happens when we add the x to the n. Now we've got a power series, and this particular power series we say is centered at 0. Now, I'll explain what that means more in just a minute, but what we want to do is we want to discuss this series, and what we're interested in this series is the radius of convergence and the interval of convergence. Those are the two things that we're interested in. The interval of convergence. The interval. Those are the two things that we want to look at. And here's the way we're going to proceed. When we have a power series like this, we start out this way. We think, okay, I'm going to use the ratio test. So here I go. I'm going to use the ratio test. I'm going to let the limit as n goes to infinity, and I'm going to just proceed with the ratio test as usual. I've got x to the n plus 1 all over n plus 1 times, multiply by the reciprocal, and we've got n over x to the n. So this is very familiar to us. We know how to perform a ratio test. So this is a sub n plus 1 divided by a sub n. Now, if we simplify this a little bit, here's what we get. We get that up top we're going to get an x times n, and on the bottom we get n plus 1. Now, I'm going to do this. I'm going to go ahead and pull out that absolute, or the n over n plus 1. We know that's positive. And since the limit is involving n, I'll just pull that out here and then keep the absolute value around the x. Now, remember the ratio test tells us that if this limit is less than 1, then the series converges. Now, we know that this part right here, this limit is 1. This part right here with the limit as n goes to infinity of n over n plus 1 is 1. So what we've got here is 1 times the absolute value of x. So now we have to make a determination, does this series converge? Or more specifically, under what conditions does it converge? Well, it converges when this is less than 1, because that's the condition of the ratio test. In other words, it converges when x is between -1 and 1. That's when the series converges. Now, at this point, I can say this. I can say the radius of convergence, which I'll denote by r, is equal to 1. Because if you look at the width of this, we think of the radius like the radius of a circle. In other words, I can say 1 minus a -1 divided by 2, and that's midway. That's half the length. So here we have 2 over 2, which is 1. And that's the radius of convergence. So if you think of the -1 at one end of the circle and 1 at the other, what's the radius? Well, it's 1. Okay, so that's the radius of convergence. Now, we don't really know the interval of convergence yet. We've got this. So you could say, well, the interval of convergence is between -1 and 1. If x is in there, it converges. But we want to go a step further and say, well, what happens when x is equal to -1? Or what happens when x is equal to 1? So we want to test those two ends. And the way we do that is we go back and I'll say, okay, well, what if x is equal to -1? So let's look at our series. We got n goes from 1 to to infinity. And in place of x, I'm going to put -1. And everything else stays the same. Now, if I do that, we know that this series converges. This converges by alternating series. Okay? It's an alternating series. So this particular one converges. So when we talk about the interval of convergence, we're definitely going to include -1. Now let's try x equals 1. If we look at x equals 1, we got n goes from 1 to infinity, 1 over n. Well, this diverges because this is a harmonic series. It's a well-known divergent series. So we're ready now to write the interval of convergence. The interval of convergence is going to go like this. It's going to be -1 included, comma 1 not included. So in this particular series, we know it has a radius of convergence to be 1 and an interval of convergence to be this. This is our interval of convergence. Now, let's look at another series. Let's suppose that we have this. Let's suppose that we have x to the n up here, and down here we have n factorial, and let's say n goes from 0 to infinity. And we want to talk about this series. Does it converge or not? And if, what is the interval of convergence? What is the radius of convergence, and so forth. Now, if you look at this one and we do the ratio test. Okay, so here we go. We've got x to the n plus 1 over n plus 1 factorial. And then up here, n factorial, x to the n. Okay, here's what we have. Now, simplifying gives us something where we can look at and probably take the limit. Now, I'm going to go ahead and simplify the x's. Here we've got x. X to the n plus 1 divided by x to the n is just x. And then here we've got n factorial. Down here, n plus 1 times n factorial. And these ones will cancel. Now, you'll notice that when we get to this point right here, let me go ahead and write it where we can clearly see what's happening. This is 1 over n plus 1, absolute value of x. Now, this is 0. This right here, this limit is 0. Well, so this whole thing, this limit is going to be 0. And it doesn't matter what we choose x to be. That limit right here is 0. So what we would say is, well, this converges for all x. So we would say the interval of convergence is -infinity to infinity. And we could talk about the radius of convergence of being infinity. So that's an example where it converges for everything. Okay, now let's look at another example. Let's suppose that we've got this series. We've got n goes from 0 to infinity, and we've got n factorial x to the n. Now, I'm going to do the ratio test just like usual. So here I go. I've got the limit as n goes to infinity of n plus 1 factorial x to the n plus 1 divided by n factorial x to the n. Okay. And if we go about to simplify this in the usual manner, we get this. We get n plus 1 times n factorial. And then we've got n factorial down here. and then we've just got an x. Now, of course, the n factorials cancel. Now, this is going to be infinity. No matter what we choose x to be, this is going off to infinity. Now, the only exception to that is if x equals 0. So this thing only converges if x equals 0. So we say the radius of convergence is 0. Okay, I think this is probably enough to get those of you that missed class started on practicing some of these problems. And if you have any questions, you can contact me or ask in class next time.